Simple question. The sky is blue, but why? Not what makes it blue. That assumes something makes it blue, creates blue, produces blueness from nothing. The question is more fundamental. Why blue and not red? Why blue at noon and orange at sunset? Why does the same sky, the same atmosphere, the same sun produce such different colours depending on when you look? And if the sky can change colour, is the sky actually any colour at all? Now consider the rainbow. Colours spread across the sky after a storm. Where do they come from? The raindrops. But water is clear. Hold a glass of it, and you see no colour. The light? But sunlight is white. Look at it directly, and you see no rainbow. Something is revealing colours that seem to exist nowhere. And your red shirt, why is it red? Because it's made of red fabric, is no answer. What makes fabric red? Red dye. But what does red dye actually do? What is the mechanism by which certain substances appear certain colours? Here is the matter that unites all these questions. For 2,000 years, we assumed colours were created by objects and circumstances. But what if colours are not created at all? What if they exist already, hidden, combined, waiting, and objects merely select which colours reach your eye? One principle. Every colour you have ever seen. The sky is not blue. The apple is not red. Light is not white. And once you understand why, you will never see the same way again. You think you understand light. You wake each morning beneath a blue sky. You see a red apple on your table. You watch the sun paint the evening clouds in orange and crimson. And you imagine, because you have always imagined, because everyone has always imagined, that you comprehend what is occurring before your very eyes. You are mistaken, not slightly mistaken, fundamentally, catastrophically wrong about something so basic, so constant, so familiar, that you have never thought to question it. The error is this. You believe that white light is pure, simple, fundamental, the most basic form of illumination, unsullied and complete. And you believe that colours are somehow created, manufactured by objects and media that act upon this pristine substance. The prism, you have been taught, adds something to light. The sky generates blue. Your red shirt makes redness. Every proposition in that sequence is false. What if I were to tell you that white light, that most ordinary, unremarkable substance streaming through your window at this very moment, is in truth the most complex phenomenon in your visual field, that it contains within itself every colour you have ever witnessed or shall ever witness, that the rainbow is not created but revealed, present all along, hidden in the very light you thought you understood. This is not metaphor. This is not poetry. This is demonstrable truth. Consider a beam of sunlight passing through a prism of glass. You have seen this, perhaps in a schoolroom, perhaps through a crystal hanging in a window. Colours emerge: red, orange, yellow, green, blue, violet, spread in an elongated spectrum upon whatever surface receives them. For 2,000 years, natural philosophers observed this phenomenon and drew what seemed the obvious conclusion. The glass creates these colours. The prism acts upon pure white light and manufactures the rainbow from it. But attend to something those philosophers failed to notice. The colours always appear in the same order: red at one extreme, violet at the other, orange, yellow, green, blue between them, invariably arranged, never deviating, never reversing. Whether the prism is made of glass or crystal or water, whether the light enters from this angle or that, the sequence remains fixed. Why? If the prism were creating colours, imposing them upon light through some modification of its own nature, Why should those colors always arrange themselves identically? Creation is variable. Circumstance should produce varying results. A painter applying color to canvas produces different effects depending on brush, pressure, pigment, surface. But the prism produces the same spectrum every time. This regularity hints at something the creation theory cannot explain. What if the colors are not being made, but being separated? What if they existed within the white light all along, combined in perfect mixture, awaiting only an instrument capable of pulling them apart? The error most make is assuming that because they see white, white must be simple. But consider, when you hear a chord struck upon an instrument, you perceive a single sound. Yet that sound contains multiple notes, multiple vibrations, combined into unified experience. Your ear integrates. It does not analyze. The chord sounds like one thing, but it is composed of many. Is it not possible that your eye does the same with light? When all colors arrive at your eye together, you perceive white. Not because white is simple, but because your eye integrates complexity into a single sensation. The unity is in the perception, not in the thing perceived. For 2 millennia, the doctrine of Aristotle held dominion over natural philosophy. Colors, he taught, were produced by the mixture of darkness with light, as if shadow and brilliance could mingle like wine and water. White was pure light, black was pure darkness. Every color between arose from their various proportions. This seemed eminently reasonable. Is it not evident that blue appears at twilight, when darkness encroaches upon light, that colors grow richer and deeper as they approach shadow? The theory matched appearances, or so it seemed to minds insufficiently rigorous in their examination. But this is precisely backwards. Darkness is not a substance that can mix with light. Darkness is merely the absence of light, no more capable of combination than silence is capable of mixing with sound to produce music. The theory that satisfied philosophers for 20 centuries was not merely incomplete, it was built upon an error so fundamental that every conclusion drawn from it was necessarily wrong. And here is the matter that should give you pause. This error persists. Ask any person whence cometh the blue of the sky, and they shall speak vaguely of air, of atmosphere, of some property of the heavens that generates blue. Ask whence the green of leaves, and they shall say the leaf produces green. The language of creation pervades all discussion of colour, encoding the ancient error into our very grammar. We say the sky is blue, the apple is red, as though colour were an intrinsic property, like shape or weight, something the object possesses in itself, independent of circumstance. But notice how your language betrays you to false thinking. Notice how every statement of colour assumes what should be questioned. The world remains opaque to itself because we begin from error. Let this be your first transformation. From this moment, when you see any colour, pause. Ask not, what is producing this colour, but rather, what might be revealing a colour that was already present. The question changes from manufacture to selection, from creation to revelation. If white light contains all colours hidden within it, and I shall demonstrate that it does, then every coloured thing you see is not a maker of colour, but a selector of it, a filter, an instrument of separation. But this requires proof, not assertion. And the proof begins with a question that the creation theory cannot answer. If colours are created by prisms, why can those colours not be further changed? Why, when you pass a single colour through a second prism, does it emerge unchanged? The red apple on your table is not red. I ask you to hold this statement in mind, to resist the immediate objection that rises in your throat. You have seen apples. You have seen their redness. Surely the apple possesses this colour, as it possesses its shape, its weight, its texture under your hand. But it does not. The apple possesses no redness whatsoever. What the apple possesses is the capacity to destroy. When white light falls upon that apple, and we have established that white light contains all colours combined, a violent process occurs. The apple absorbs blue light. It absorbs green light. It absorbs violet light. These rays enter the apple's surface and are annihilated, their energy transformed into minute heat, lost forever to perception. Only red survives. Only red rays reflect from the apple's surface, travelling outward to reach your eye. You see red, not because the apple creates redness, but because the apple eliminates everything except red. Your perception of that red is a record of destruction, not creation. The apple is not a painter, it is a murderer of light, and therefore your red shirt is an enemy of blue, green, and violet. Your blue curtains are destroyers of red, orange, and yellow. Every coloured object you have ever seen operates by this same principle: selective absorption, which is to say, selective annihilation of most of the spectrum. This inverts our intuition entirely. We imagine coloured objects as possessing their colours positively, as properties they have. We think of the apple as having redness, the way it has roundness. But roundness is intrinsic. The apple is round, regardless of how we observe it. Redness is not intrinsic. It depends entirely on what light is present and what the apple does to that light. Change the illumination, and you change the colour. This is demonstrable. Take a piece of red cloth into a room illuminated solely by green light. What colour does the cloth appear? Not red, not dark red, not any shade of red whatsoever. Black, utterly black. Why? Because the cloth can only reflect red rays, but no red rays are present in the illumination. The green light strikes the cloth, and the cloth absorbs it completely. That is what makes the cloth red under normal circumstances. This destruction of everything except red, with no red light available to reflect, nothing reaches your eye. The cloth appears as dark as if no light fell upon it at all. Where is the redness now? It was never in the cloth. The error is treating colour as an absolute property rather than a relationship. We ask, what colour is this object? When we should ask, what light does this object permit to reach my eye under these conditions? The first question assumes colour resides in the object. The second question correctly locates colour in the transaction between light, object, and observer. This explains phenomena that otherwise seem mysterious. You have noticed, perhaps, that a white page appears white under both sunlight and candlelight, though the light falling upon it differs dramatically. Sunlight contains the full spectrum in roughly balanced proportions. Candlelight is heavily weighted toward red and orange, deficient in blue. The page should look different under these two illuminations, and indeed, if you measure the light reaching your eye, it is different. Yet both appear white. Why? Because whiteness is not a fixed sensation, but a judgment. Your visual system corrects for the illumination, interpreting as white whatever contains the expected mixture of colours for that light source. You do not perceive wavelengths directly. You perceive relationships between wavelengths interpreted by a system that constructs colour from comparison. You have never simply seen a colour. You have always interpreted one. Now consider the implications of this. If objects appear coloured through selective destruction of light, then the colours available to perception are entirely determined by the colors present in the illumination. Under light containing only blue and green rays, no red, no orange, no yellow, a red apple appears black. A yellow banana appears nearly black. A white page appears blue-green. The colors of these objects vanish because the light needed to reveal them is absent. This is why painters and merchants have learned through bitter experience that fabrics and pigments must be examined under the light in which they will be used. A dress purchased in the shop may disappoint at home. A color matched under one illumination may clash under another. These are not failures of memory or judgment. They are the inevitable consequence of color being a relationship, not a property. And therefore, when you see any colored object, silently translate that blue vase. This object is destroying red, orange, yellow, and green, permitting only blue to reach me. That yellow flower. This object is destroying blue and violet, permitting only yellow, and some adjacent colors to survive. The visual world becomes a field of selective filtration rather than a gallery of possessed properties. Everywhere you look, annihilation is occurring. Only the remnants reach your eye. But here is a question that should now trouble you. If colors are in the light, and objects merely select which colors survive, how do we know that colors exist in light prior to any interaction with objects? How can we demonstrate that the spectrum is not created by the prism, the raindrop, the glass of water that seems to produce it? We have asserted that white light contains all colors. We have argued from the regularity of the spectrum that something other than creation must be occurring. But assertion is not demonstration. Argument is not proof. Natural philosophy demands more than plausibility. It demands the crucial experiment, the single demonstration that decides between competing theories by producing an outcome that only one theory can explain. Such an experiment exists. It is elegant in its simplicity and devastating in its implications. And it begins with a second prism. One experiment, elegantly simple, proved what millennia of speculation could not resolve. The design proceeds thus. Take a beam of sunlight entering a darkened chamber through a small aperture. Allow this beam to pass through a prism, producing the familiar spectrum upon a screen, red at one extreme, violet at the other, all intermediate colors displayed in their invariable order. Now make a small hole in that screen, positioned to permit only a single color to pass through. Let us say green. Only the green rays continue beyond the screen. All other colors are blocked. These isolated green rays now encounter a second prism. Here is the question that distinguishes between theories. What will emerge from this second prism? If the first prism created the green color by modifying white light, if the glass somehow manufactured greenness by acting upon the light that passed through it, then the second prism should modify the green further. It should produce yet another transformation. Creation should continue. The glass should impose yet more modification upon the light. But if the first prism merely separated green from the other colors that were always present in the white light, if it revealed rather than created, then the green should emerge from the second prism unchanged. Green should remain green. There would be nothing further to separate, nothing more to reveal. This is the crucial experiment. The two theories predict different outcomes. One must be wrong. Pass the green rays through the second prism. They bend. They possess what we may call refrangibility, the tendency to deviate from their straight path when passing between transparent media. But they produce no new colors. They remain purely green. The color cannot be further divided because it is already fundamental. The prism possesses no creative power. It can only separate what was already combined, and therefore green is not a modification of white light. Green existed within white light all along, mingled with red and orange and yellow and blue and violet, combined into apparent simplicity. The first prism did not paint the spectrum, it analysed it, from which it appears that white light is composite. Within every ray of ordinary daylight exist all the colours visible to human sight: red, orange, yellow, green, blue, indigo, violet, and every gradation between them. These are not created by circumstance. They are fundamental, irreducible. Each colour possesses its own intrinsic nature, including its own degree of refrangibility, its own angle of bending when passing from air into glass and back again. Red bends least, violet bends most. The intermediate colours occupy intermediate positions, and this property is fixed, belonging to the ray itself, unchangeable by any subsequent interaction. This is why the spectrum always appears in the same order. Red, bending least, appears at one edge. Violet, bending most, appears at the other. The intermediate colours arrange themselves according to their intermediate degrees of bending. The regularity is not arbitrary. It reflects the intrinsic properties of the colours themselves. The crucial experiment accomplishes more than proving the composition of white light. It demonstrates a method, the method by which natural philosophy advances. When two theories both explain existing observations, design an experiment where they predict different outcomes. One theory survives, the other falls. This is not rhetoric. This is not persuasion. This is demonstration. The creation theory predicted that green should change when passed through a second prism. The separation theory predicted it should not. The green remained green. The question is settled, but the experiment offers more. Run it in reverse. Take the colours separated by the first prism, all of them, the full spectrum, and pass them through a lens that brings them back together, converging upon a single point. What colour appears at that point? White, pure white, the same white that entered the first prism. Nothing is lost. Nothing is created. The colours that were separated recombine into the white from which they came. The experiment demonstrates both analysis and synthesis, decomposition and recomposition. The prism that separates can be followed by the lens that reunites, and white light is restored. This is the foundation upon which all understanding of colour must rest. The colours are in the light. It is manifest that we have been perceiving incorrectly for 2 millennia. What philosophers took for simple white light is actually the most intricate mixture. What they took for complex, the rainbow of colours, displays the simple, fundamental components. The direction of analysis runs precisely opposite to intuition, and here is a principle that extends beyond optics. Complexity often hides in apparent simplicity, and simplicity often hides in apparent complexity. The wise philosopher does not trust the appearance of simplicity. He tests it. When you see a rainbow after a storm, you witness the crucial experiment repeated by nature countless times. Each raindrop acts as a prism, separating the white sunlight into its hidden colours. The colours were present in that light before any drop touched it. The rainbow does not manufacture beauty from nothing. It reveals what was always there. You can observe this yourself on any sunny day. Hold a clear glass of water in sunlight at various angles. Watch for the prismatic edges where colours appear, brief flashes of spectrum at the water's surface or where light exits the glass. The equipment differs from the formal experiment, but the principle is identical. You are seeing white light decomposed into its components. The analysis cannot proceed further with colors already isolated. The components are fundamental. But here is the matter that should now occupy your inquiry. The principle is established, yet the applications remain unexplored. If colors are in the light, why does the sky appear blue? The sky is not a prism. No refraction separates colors as they pass through atmosphere. Yet the sky displays one color, blue, from morning until evening, horizon to horizon. Why? If objects appear colored through absorption, why does the distant mountain appear blue when its rocks and trees are grey and green? Distance should not change a color. An apple remains red whether you stand near or far from it. Why should mountains turn blue at distance? And the rainbow, if each raindrop acts as a prism, why do we see an arc? Why not a confused scatter of colors from every direction? Why that precise band of spectrum, curved against the sky? The principle has been proven. The mechanisms by which it manifests in daily experience, these remain to be examined. Look up. The sky is not blue. I ask you to absorb this statement as you absorb the statement that the apple is not red. The sky possesses no blueness. Nothing in the atmosphere has the property of being blue. No substance hangs above you painted in azure. What happens is this. The air contains innumerable minute particles, unimaginably small, far smaller than visible light itself. When white sunlight enters the atmosphere and encounters these particles, a phenomenon occurs that differs from both refraction and absorption. The particles scatter light, but, and here is the principle upon which everything depends, they do not scatter all colors equally. Shorter wavelengths scatter far more readily than longer wavelengths. Blue and violet, with their shorter wavelengths, deflect from their straight paths with dramatically greater frequency than red and orange, whose longer wavelengths pass more directly through. The relationship is not subtle, it is mathematical and precise. Scattering increases as wavelength decreases, following an exact proportion. And therefore, when you look at the sky away from the sun, what reaches your eye? You see light that was not travelling toward you. You see light that was heading elsewhere, toward the horizon, toward space, toward any direction but your eye, until particles deflected it sideways, redirecting it toward your position. Which colours are most likely to be deflected? Blue and violet. Which colours continue more directly forward? Undeflected, red and orange. The sky appears blue because blue light has been scattered toward you from all directions. You are seeing sunlight that has been knocked off course and sent wandering through the atmosphere until, by chance or by the mathematical necessity of countless deflections, it arrives at your eye. The sky is not coloured. The sky is a scattering phenomenon. Now consider the sun at noon. It appears white, or rather, white-yellow. Why? Because you are seeing light that has taken a relatively short path through the atmosphere. Some blue has scattered away, but much remains. The sun appears roughly balanced across the spectrum. But watch the sun set. As it descends toward the horizon, its light must traverse a far greater thickness of atmosphere to reach your eye. The path length increases dramatically. What happens to the blue light during this longer journey? More of it scatters away. With every additional mile of atmosphere, more blue is deflected from its path, sent wandering in other directions. By the time the remaining light reaches your eye, the blue has been largely stripped away. What remains? Red, orange, the colours that survive the long passage. This is why sunsets blaze. The same mechanism that makes the sky blue makes the setting sun red. One phenomenon, two complementary appearances. At noon, you see scattered blue arriving from all directions. At sunset, you see the light that was not scattered, the survivors of the long journey through atmosphere. And therefore, the sunset's red is the sky's blue inverted. Consider this thought experiment. Imagine you could eliminate the atmosphere instantly, vanish every particle from the air. What colour would the sky be at noon? Black. Pure black. The sun would appear as a white disk in the void, surrounded by visible stars. The darkness of space would press right down to the surface of the earth. Why? Because with no particles to scatter light, no light would be deflected toward your eye from the sky. You would see only the light travelling directly from the sun, nothing from the dome above you. The blueness of sky is not in the sky. It is sunlight, scattered by particles, redirected to your eye. Remove the scatterers, and the blue vanishes. There is nothing to see. You have experienced variations of this principle without recognizing them. At high altitudes, where the atmosphere is thinner, the sky appears deeper blue, darker, richer. Why? Because with fewer particles above you, less scattering occurs, and the sky appears closer to the black of space. The blue that remains is concentrated, intense. On hazy days, when moisture and particles thicken the air, the sky appears paler, washed out, whitish. Why? Because the additional particles scatter so much light in all directions that the blue becomes diluted by light of other wavelengths. Too much scattering muddles the effect. The sea appears blue for related reasons, not because water is blue, but because water scatters shorter wavelengths more readily than longer ones, and because it reflects the blue sky above it. The two effects combine to produce the blue you see. Even shadows participate in this principle. Examine a shadow on a sunny day. Not merely dark, but tinged with blue. Why? The shadow is blocked from direct sunlight, but it is not blocked from the sky. It receives scattered blue light from the entire dome above, light that reaches it from all directions while the direct sun cannot. The shadow is illuminated by the blue sky. It appears blue. Painters have known this for centuries without understanding why. They paint shadows blue, and their pictures look right. They paint shadows grey, and something seems wrong, lifeless, false. The eye recognizes the truth, even when the mind cannot articulate it. Now you possess the articulation. Watch the sky throughout a single day. At noon, pale blue sky, white-yellow sun. At sunset, deepening orange and red sun. Sky transitioning through colours as the scattering geometry shifts. At twilight, deep blue lingering where the sun has set, fading through purple toward the black of night. You are watching the same principle operate under changing conditions. The light's composition hasn't changed. The sun emits the same spectrum at sunset as at noon. What changes is the path length, how much atmosphere the light must traverse, how much blue is scattered away before arrival. Every sunset demonstrates the mechanism. You had only lacked the principle to decode it. But the sky scatters, and objects absorb. These are distinct mechanisms. What of the rainbow? It is neither scattering nor absorption. It operates by refraction, as the prism does. Yet no prism hangs in the sky after a storm. What creates that arc of colours? And why an arc? Why not colours scattered randomly from every raindrop in every direction? The rainbow holds a deeper lesson, that what we see depends not only on light and object, but on where we stand. There is no rainbow in the sky. I ask you to hold this statement as carefully as the others. No object hangs in the air displaying bands of colour. No thing exists at which you could point and say, there it is. The rainbow is not located anywhere. What exists are countless water droplets suspended in the air, each one a tiny sphere. each one acting as a miniature prism. But here is the insight that transforms understanding. From any single drop, only one colour reaches your eye. Only one. Consider the path of light through a raindrop. White light from the sun enters the drop's front surface, refracting, bending, as it passes from air into water. This light continues to the back inner surface of the drop, where it reflects. Then it travels back toward the front of the drop and refracts again as it exits from water into air. Each colour, possessing its own degree of refrangibility, bends at its own angle. Red bends least upon entry and exit. Violet bends most, and therefore the colours exit the drop at slightly different angles. Here is the crucial point. Your eye occupies one position, one specific location in space. From any single drop, the red rays exit at approximately 42 degrees from the incoming sunlight. The violet rays exit at approximately 40 degrees. The other colours fall between. But you cannot see all these colours from one drop. Your eye can only receive light travelling directly toward it. From a drop positioned such that its red rays reach your eye, the violet rays pass above you, missing entirely. From a drop positioned such that its violet rays reach your eye, the red rays pass below. Each drop contributes exactly one colour to your perception, and therefore the rainbow you see is constructed from thousands of different drops. The red band comes from drops at a higher angle, drops positioned such that their 42-degree red rays happen to reach your eye. The orange band comes from drops slightly lower, yellow, green, blue, violet. Each band comes from drops at progressively lower angles, each drop contributing its single colour at the angle that happens to align with your position. The rainbow is not a thing, it is a relationship between the sun's position, the positions of countless drops, and your position. Change any element, and the rainbow changes. Move sideways, the rainbow moves with you. It maintains its angular relationship to your position and the sun. But the drops composing it change. The red you see now comes from different drops than the red you saw a moment ago. You are seeing a different rainbow, constructed from different water, yet appearing identical because the geometric relationship remains the same. You and a companion standing 20 feet apart see different rainbows. Same colours, same arc, same apparent position in the sky, but composed of light from entirely different drops. The rainbow each of you sees is private to your position. Where is the rainbow? The question is malformed. The rainbow is not located anywhere. It exists only in the transaction between sun, water, and observer. This is why you cannot reach the rainbow's end. As you walk toward it, it recedes, because the angular relationship that creates the bow maintains itself around your moving position. You carry your rainbow with you. It is yours, and yours alone, and it goes where you go, while seeming to stay always at the same distance. The pot of gold is safe. No one can reach what exists only in relationship. Consider what this reveals about perception itself. Some phenomena exist in objects. The apple's roundness is in the apple. You can feel it, measure it, confirm it exists independent of your position. But the rainbow's location is not in the drops. It depends entirely on where you stand. The rainbow teaches that some of what we see is not simply out there, waiting to be observed. Some of what we see is constituted by the act of observation itself, by the relationship between observer and observed. This need not frighten you. It should humble you. You can observe this principle directly. On a sunny day, take a spray bottle or garden hose and create mist while standing with the sun behind you. A rainbow will form in your mist. tiny perhaps, but displaying the full spectrum. Now move your head from side to side. The bow moves with you. This is not an illusion. This is not a trick. This is the demonstration that the rainbow exists only in relationship to your position. Change your position, and you see different light from different drops at the same angles. The colors are real. The light is real. The drops are real. But the rainbow, the arc of color you perceive, is not located in any of them. It is located in the geometry, pure geometry, made visible by light and water. Consider also why the rainbow is an arc, why that particular curve against the sky. All drops at the same angle. From the antisolar point, the point in the sky directly opposite the sun, from your perspective, send the same color to you. Drops at 42 degrees from that point send red. Drops at 40 degrees send violet. These equal angles form a circle around the antisolar point, but you stand on the ground. The lower portion of that circle lies below the horizon. You see only the upper arc, the section of the full circle that appears above the earth. From an aeroplane or mountain peak, with the horizon lower, you can see a fuller arc, sometimes even a complete circle of rainbow around the antisolar point. The geometry does not change. Only what portion of it lies above your horizon changes. The rainbow is mathematics made manifest, geometry painted in the sky. And now observe, we have traced three distinct mechanisms by which the single truth about light manifests as the colored world. Objects absorb selectively, destroying most colors, permitting remnants to reflect toward us. Atmosphere scatters differentially, deflecting blue more readily, leaving red to pass through. Raindrops refract geometrically, separating colors by their different degrees of bending, each drop contributing one color at the angle reaching our eye. Three mechanisms, one underlying truth. Colors are in the light. But these explanations have been separate. Can we see the unity? Can we perceive the single principle operating through diverse manifestations? Can we transform these accumulated facts into a new way of seeing? One question that decodes all color phenomena. The mechanisms await integration. The scattered pieces must reveal their pattern. You now possess knowledge. Separate facts, distinct mechanisms, individual explanations for individual phenomena. The sky scatters blue. Objects absorb selectively. Rainbows refract through geometry. White light contains all colors. Each principle stands proven. But knowledge is not yet understanding. Understanding arrives when the scattered pieces reveal their pattern, when separate facts crystallize into a single way of seeing. And that transformation begins not with an answer, but with a question. A different question than you have ever asked about color. For your entire life, when you have seen color, the question that arose, if any question arose at all, was some variant of this. What created this color? What made it? What produced this blue, this red, this orange before me? This question encodes the ancient error. It assumes color is manufactured. It seeks a creator, some object, some process, some circumstance that brings color into existence from nothing. But we have learned that colors are not created. They exist already, hidden in white light, awaiting only the circumstance that reveals them. And therefore, the question must change. Instead of asking, what created this color? Ask this, what revealed this color? What filtered it? What selected it from the light available? What relationship of source, medium, and position produced this particular appearance at this particular moment? This is the unified question, and it applies to everything you see. Let us test it. The sky is blue. What revealed that blue? the scattering of sunlight by atmospheric particles, a process that deflects shorter wavelengths preferentially, redirecting blue toward your eye from all directions while allowing red and orange to pass more directly through. The apple is red. What revealed that red? The selective absorption of the apple's surface, a process that destroys blue, green, and violet, permitting only red to reflect toward your eye. The rainbow displays its arc. What revealed those colors? The refraction through countless water droplets, each drop separating white light by the different bending angles of its components, each drop contributing one color at the angle that reaches your specific position. The sunset blazes orange. What revealed that orange? The extended path through atmosphere, so much atmosphere that most blue is scattered away, leaving only the longer wavelengths to survive the journey. One question, 4 phenomena, the same underlying structure. And now consider phenomena you may not have examined. The shadow on a sunny day appears faintly blue. What revealed that blue? The shadow is blocked from direct sunlight, but not from the sky. It receives scattered light from the entire blue dome above, illuminated by the same principle that makes the sky blue. The shadow is lit by skylight. The distant mountain appears blue, though you know its rocks are grey and its trees are green. What revealed that blue? The intervening atmosphere. Miles of air stand between you and that mountain, and those miles scatter blue light into your line of sight, the same scattering that colours the sky. The more distant the mountain, the more atmosphere intervenes, the more blue accumulates. You are not seeing the mountain's colour. You are seeing the atmosphere's effect layered before it. The deep water of a lake appears blue, though a glass of that same water appears clear. What revealed that blue? Over short distances, water absorbs so little light that it appears transparent. But over longer distances, the depth of a lake, the span of the sea, water absorbs red wavelengths more readily than blue. The blue that survives the long passage through water reaches your eye. The red does not. One question decodes all of it. What revealed this colour? But the question does more than provide explanations. It transforms how you perceive. When you ask, what created this colour? You position yourself as a passive observer of a world that manufactures appearances for you. Colour happens to you. You receive it. When you ask, what revealed this colour? You position yourself as an investigator of relationships. Colour becomes a transaction between light source, intervening medium, object, and your position. You participate in colour. You occupy a specific location in a web of relationships that produces your particular perception. This shift matters. Consider, 2 observers standing in different positions see different colours from the same drops of water. Each sees their own rainbow, constructed from different light paths. Neither is wrong. Neither sees the true rainbow. There is no true rainbow independent of observer position. The rainbow exists only in relationship. How much else that we perceive exists similarly in relationship rather than in objects themselves. The colour of a dress in a shop differs from its colour at home because the illumination differs, and colour is a relationship involving illumination, not a property independent of it. The colour of a painting shifts as you move from natural to artificial light because the available wavelengths change, and the painting reveals only what the light contains. The colour of the evening sky differs from the morning sky, though the sun is at the same angle because the atmosphere has accumulated different particles throughout the day, and what you see depends on what does the scattering. Once you possess the unified question, patterns emerge everywhere. And here is a principle that extends beyond color entirely. Complex phenomena often reduced to simple principles operating through varying circumstances. The sky, the sunset, the rainbow, the shadow, the distant mountain, the deep water, all different appearances, all produced by the same underlying truth. Colors are in the light. Circumstances select which colors reach the observer. This is how natural philosophy advances, not by cataloguing endless separate facts, but by discovering the fewer principles from which those facts follow. The mind that possesses the principle can generate the facts. The mind that possesses only facts must memorize endlessly without comprehension. You now possess the principle. Let us examine what it reveals about perception itself, about the boundary between what exists and what you experience. You do not see the world. I ask you to sit with this statement, to resist the immediate objection. You have eyes. Light enters them. Images form. You perceive. Surely you see the world. What else could you possibly be seeing? But consider the path by which what you call seeing occurs. Light departs from a source, the sun, a candle, a fire. That light already possesses a particular composition. Not all sources emit all wavelengths equally. The sun provides a roughly balanced spectrum. A candle flame is heavy in red and orange, deficient in blue. The light that begins the journey is already filtered by its origin. This light travels through atmosphere, which scatters some wavelengths and transmits others. The light that continues is already altered by its passage. This light strikes an object, which absorbs some wavelengths and reflects others. The light that departs the object is already filtered by the surface it encountered. This remaining light travels through more atmosphere to reach your eye. More scattering, more filtering, more alteration. This twice filtered, multiplied scattered light finally enters your eye. But your eye does not respond to all wavelengths. It responds only to a narrow band, roughly from red to violet. Wavelengths shorter than violet or longer than red produce no sensation whatsoever. The eye receives only what it is built to receive. And this partial signal, light that has been filtered by source, by atmosphere, by object, by atmosphere again, and now by the limitations of the eye itself, this signal is processed by the brain. The brain interprets, it compensates for illumination, it constructs color from comparison, it fills in gaps, it makes judgments. What you experience as seeing is the end product of cascaded translation. You do not perceive light. You perceive your brain's interpretation of signals caused by light that has undergone multiple transformations before reaching you. Whence it follows that perception is not a window, it is a translation. This need not terrify you, but it should humble you. Consider the spectrum of radiation that exists beyond what you can see. Beyond violet lies a range of shorter wavelengths, what natural philosophers might call ultraviolet rays. These rays exist. They strike objects around you constantly. They affect surfaces, causing some materials to fade or change, but they produce no sensation in your eye. You are blind to them. Beyond red lies another range, longer wavelengths, what might be called infrared. These too exist. Warm objects emit them. Fire radiates them. Your own body produces them, but they produce no visual sensation. You are blind to them as well. The spectrum you perceive, the rainbow of colors from red to violet, is a narrow window in a vast range of radiations that extend far beyond in both directions. What else exists that you cannot sense? Your window of perception is not determined by what exists, but by what your biological apparatus can detect. A different apparatus would reveal a different world. The boundaries of your perception are arbitrary from nature's standpoint, merely the particular range that your eyes happen to respond to, and therefore you do not see reality. You see a translation of reality, a translation shaped by your position, your biology, your brain's processing, and the transformations light has undergone before reaching you. But here is the wonder within the limitation. Because the translations follow lawful principles, they can be understood. Because the filtering is consistent, because scattering follows mathematical law, because absorption depends on material properties, because refrangibility is fixed and measurable, we can reason backward from appearance to cause. We can correct for illumination. We can predict color shifts. We can understand what our senses conceal. The boundary between perception and reality is real, but it is not opaque. Consider how your visual system compensates for illumination. A white page under candlelight receives dramatically different light than the same page under noon sun. Measured precisely, the wavelengths reaching your eye differ enormously. Yet you perceive both as white. Your brain compensates. It interprets as white whatever approximates the full available spectrum, for the illumination it infers is present. It constructs color constancy, the stable appearance of colors despite shifting illumination, by making judgments about the light source and adjusting your perception accordingly. This is not passive reception. This is active construction. You never simply see a color. You always interpret one. And occasionally the construction fails. You have experienced moments when color surprised you. The dress that looked different in the shop than at home. The paint that shifted between natural and artificial light. The fabric that clashed after you brought it indoors. These are not failures of memory. They are moments when the brain's compensation encountered conditions it could not fully correct for. The failures reveal the constant process, a process normally invisible because normally it succeeds. Now consider a thought experiment. Imagine a creature whose eyes respond not to the wavelengths you see, but to infrared radiation, the warmth rays that lie beyond red. What would the world look like to such a being? The sun would blaze, a torrent of infrared pouring down, but so would any warm object. Your body, radiating heat, would glow. The fire would be intensely bright in a way different from its visible flames. Warm stones that had lain in the sun would shine. Cold objects would be dark. Night would not be dark, as you experience it, not entirely. Warm creatures would still glow. The residual heat of the day's sun would radiate from surfaces. Darkness would mean only the absence of external light sources, not the absence of visibility. Now recognize that creatures' perception would be no more or less real than yours. It would be a different translation of the same underlying reality. Neither translation is privileged. Both are partial. Both reveal some truths and conceal others. You are such a creature, equipped with your particular translation apparatus, seeing your particular window of reality, blind to the rest. This recognition should produce not despair, but liberation. Because the translation is lawful, the limitations become tools. We can design instruments to detect what our eyes cannot, to extend our perception into ranges our biology excludes. We can reason about what must exist beyond our senses by tracing the implications of what we can observe. We can navigate the boundary between appearance and reality precisely because that boundary follows consistent rules. The boundary is real. You do not see things as they are, but the boundary is navigable. You can learn what it conceals, and in that navigation lies all of natural philosophy. You will never see light the same way again. This is not aspiration. This is not hope. This is consequence. Having understood that white light contains all colours, you cannot ununderstand it. The knowledge has become part of how you see. Every sunbeam that falls through your window will carry this understanding with it. Every sunset will demonstrate the principle you now possess. Every blue shadow, every distant mountain's haze, every rainbow after a storm, each will whisper its explanation to a mind now equipped to hear. True understanding is irreversible. This is not mere information storage. You have not merely added facts to a mental catalogue, facts that might fade or be forgotten, like the contents of old books. You have transformed the apparatus of perception itself. The question, what revealed this colour, has taken root. It will arise unbidden. You will find yourself decoding colour phenomena without conscious effort, seeing scattering in the sky, absorption in the apple, refraction in the rainbow, automatically, naturally, as part of how you now see. The mystery does not disappear. The mystery transforms. Consider what happens the next time you witness a rainbow. Before, you might have felt wonder at the appearance, colour appearing from nowhere after rain, an arc painted across the sky by some process you did not understand. The wonder was at the mystery. The beauty was in the unknowing. Now you will see differently. You will see white light entering drops, separating by the different bending angles of its component colours. You will see each drop contributing exactly one colour at exactly the angle that reaches your eye. You will see the arc emerging from pure geometry, all drops at the same angle, sending the same colour. The shape determined by mathematics as strict as the orbits of planets. Is this loss? Has explanation killed wonder? The error most make is believing that it has. This is the complaint of those who prefer comfortable mystery to demanding truth. But consider, the wonder at mystery was fragile. It depended on ignorance. It would have faded with familiarity, the 100th rainbow impressing less than the first, the 1,000th becoming merely ordinary, because mystery without understanding offers nothing to sustain attention. The wonder at understanding is different. It deepens with familiarity. The more you understand, the more there is to appreciate. The 100th rainbow reveals nuances the first could not. The relationship between sun angle and arc height, the faint second bow, sometimes visible outside the first, the dark band between them, where neither direct nor reflected light reaches your eye. Understanding does not diminish beauty. Understanding reveals layers of beauty that mystery concealed. The sunset you now understand will still stop you in your tracks. But now you will perceive what you see. The long passage through atmosphere, the blue scattered away, the red surviving, the geometry of light and particle and eye. You will participate in the phenomenon rather than merely observe it. You will see the mechanism operating, and in that seeing, find a wonder that ignorance could never provide. The wonder of comprehension, that something as common as light should contain such hidden complexity, that something as simple as a prism should reveal what millennia of philosophy could not discover, that the same principle, colours are in the light, should explain sky and sunset and rainbow and shadow and the blue of distant mountains, that nature should yield to inquiry at all, surrendering secrets to those patient enough to ask the right questions in the right way. This is the deeper wonder, not that rainbows are beautiful, but that rainbows are comprehensible. In the coming days, notice when your new understanding activates. You will glance at a sky and think, without willing it, scattering. You will see a shadow and observe its blue tint and think, light from the dome above. You will watch a sunset and perceive, not magic, but mechanism, and find the mechanism more magical than the magic ever was. These unbidden recognitions are signs of transformation. The understanding has become part of how you see, and there is more. What you have learned about light, you have learned about learning itself. The method by which these truths were established, proceeding from observation, questioning assumptions, designing crucial experiments, extracting principles, acknowledging limits. This method applies to everything. The content was about color. The lesson was about inquiry. When you encounter any puzzling phenomenon in any domain, on any subject, you now possess a template. Observe carefully. Question what seems obvious. Design tests that distinguish between competing explanations. Extract the principle that explains diverse observations. Acknowledge what remains unknown. Light was the subject, but the method travels with you. It works for mechanics, for astronomy, for any domain where careful observation can reveal underlying law. You have not merely learned about rainbows, you have learned how learning happens. And this, perhaps, is the most irreversible transformation of all. We have learned much about light. We have traced how white light contains all colours, how objects reveal colours through selective absorption, how the sky scatters blue while sunsets preserve red, how rainbows exist not as objects but as geometric relationships between sun and water and observer. We have transformed a question from what creates colour to what reveals colour, and found that this single transformation unlocks phenomena across the visual world. We have recognized that perception is translation, not transcription, that between us and reality stand multiple transformations, each lawful, each navigable, each concealing and revealing in equal measure. This is substantial, this is transformation, and it is a pebble on the shore. The ocean of truth lies undiscovered before us. Consider what we've not explained. We have described how light behaves, how it refracts through prisms, how it scatters in atmosphere, how it reveals itself in the spectrum's invariable order. But we have not explained what light is. We have traced its properties, not its nature. We know how it acts. We do not know what it fundamentally is. Is light a substance, a vibration, something else entirely? The questions remain open. Natural philosophy has established the laws of light's behaviour while remaining humble before light's ultimate nature. This is not failure. This is honesty. The truthful philosopher distinguishes between what can be demonstrated and what cannot yet be known. I do not pretend to understand the cause of light's properties, only that light really exists and acts according to the laws we have observed. The cause remains hidden, the effects are plain. Hypotheses about ultimate causes, speculations about what light might be in itself, independent of how it behaves. Such hypotheses have no place in careful philosophy until evidence can decide between them. Better to acknowledge ignorance than to dress speculation in the clothing of knowledge, and therefore, what we have learned matters less than how we have learned it. The method proceeding from phenomena through experiment to principle, this method applies to everything. The content was about colour. The lesson was about inquiry itself. Consider also how much remains unknown even within what we have explored. We see only a narrow band of wavelengths. There exist radiations beyond violet and beyond red that our eyes cannot detect. These radiations follow the same laws as the light we see. They refract, they scatter, they are absorbed and reflected, but we cannot perceive them directly. We are partially blind to the spectrum. What else exists that our instruments fail to perceive, that our senses cannot detect? The proper response to understanding is not satisfaction. The proper response is humility combined with continued inquiry. Every answer reveals deeper questions. Every principle established opens new domains for investigation. Every pebble found on the shore only emphasizes how vast the ocean remains. This is not discouraging. This is the nature of genuine inquiry. The joy is not in reaching a destination, for understanding has no final destination. The joy is in the exploration itself. The satisfaction is in the finding, not in having found. And there is something else, something worth pausing upon before we conclude. By comprehending light, we participate in something extraordinary. We are matter and energy, organized in such a way that we can contemplate matter and energy. We use light to see. We use the same light we investigate to perceive the results of our investigation. The eye that detects the spectrum is itself illuminated by the spectrum. The universe, through us, comprehends itself. This is not metaphor dressed as philosophy. This is simple observation. We are part of nature. Our inquiry into nature is nature's inquiry into itself. When we understand light, it is light, in some sense, coming to understand light. There is something marvelous in this, something that should give pause to any mind capable of appreciating it. The pebble we have found is not merely pretty. It is a fragment of a vast order, an order in which inquiry is possible, in which laws govern phenomena, in which patient observation yields genuine understanding. The pebble points to the ocean, and the ocean is not empty chaos. It is structured, lawful, comprehensible, waiting for minds patient enough to explore it. We have spent our time together tracing light and colour, but the pattern extends. The same patient inquiry that decoded the rainbow can decode the motions of the planets, the behaviour of falling bodies, the tides of the sea, the forces that govern all motion. One method, infinite application. This is the inheritance, not facts to be memorized, but a way of seeing. Not answers to be stored, but questions to be asked. Not a completed understanding, but the tools by which understanding advances. The phenomena were always before you. The sky was always blue. The apple was always red. The rainbow always arced after storms, but you could not see why. You could only observe that. Now you possess the principles. You understand that white light is composite, the most complex phenomenon in your visual field, containing every colour you will ever see, awaiting only the circumstance that separates and reveals. You understand that colour is relationship, not something objects possess, but something that emerges from the transaction between light and object and observer. You understand that perception is translation, that you do not see reality directly, but through a lawful process that can be decoded, corrected, and navigated. You understand that understanding transforms perception, that knowledge once gained cannot be ungained, that the question, what revealed this colour, will now arise unbidden whenever you encounter colour. And you understand that inquiry continues, that what we have found is a beginning, not an end. The sky is not blue. The apple is not red. Light is not white. And in that triple negation lies a transformation of understanding that once achieved can never be undone. You will never look at light the same way. You will never look at colour the same way. You will never mistake appearance for reality without remembering that between them stands a lawful process, patient, waiting to be analysed. This is the gift of careful observation, married to mathematical reason. The world becomes transparent to itself. The phenomena were always before you. Now you possess the principles, and thus light, which appears the most familiar of all substances, reveals itself as the deepest teacher. For in understanding how we see, we begin to understand the vast space between what is and what appears to be. And in that space lies all of natural philosophy.